In our first example, we're going to take it a little bit easier. So what we're going to do is we're going to evaluate integral over some curve c x squared z ds for c a helix given by x equal cosine t, y equal to 2t, and z equal to sine t for 0 less than or equal to t less than or equal to pi. And just so that you all know, here's x, y, z. This helix means, see, starts at cosine 0, so x starts like this. It's going to be kind of like a spiral. That's what this shape is saying, except for it actually only goes from 0 to pi, so really it's going to stop here, I guess, kind of. And you got to imagine it starts at y equals 0 and ends up here at y equal 2 pi, like that. So that's a visualization of the shape we're talking about here. But since they gave us the parameterization of the curve, we actually don't even need to know what it looks like. So the parts of my function, the parts of my integral are going to be, I've got f is equal to x squared z. And since I've already been given this parameterization, I have my x of t, y of t, z of t. It's cosine t, 2t, sine t, and I have my, here's my a, here's my b. Actually, yeah, let's do that with different colors for everything. So in this problem, I was given my parameterization. So here's my x of t, here's my y of t, here's my z of t. Parameterized curve for x, y, z developing in time. And then I'm told that time runs from lower bound a equals 0 to upper bound b equal pi. And so if I look at the thing I'm supposed to evaluate, I just need to think about converting so that I have everything depend on time instead of the curve c and my variables x, y, z. So I was given f equal x squared z. So I'm going to go ahead and convert this so that I have my x of t here and my z of t here. So that's just cosine squared t sine t, f a function of only time. And then my ds I know should be equal to x prime of t squared plus y prime of t squared plus z prime of t squared. So if I have x equal cosine t, I know that x prime is minus sine t. If I have y equal 2t, I know that y prime is 2. And if I have z equals sine t, then I know that z prime is cosine t. So my ds is going to be square root negative sine t squared plus 2 squared plus cosine t squared. It's going to be square root sine squared t plus 4 plus cosine squared t. And I remember that sine squared plus cosine squared is just 1. So that's going to be square root 1 plus 4 or square root 5. And so I can say that my curve c, x squared z ds, is the integral of f that depends only on t, cosine squared t sine t. Oops. Left off my dt the whole time I was calculating this. That's my bad. My ds is root 5 dt. So I change my x squared z by plugging in x of t, z of t, so that it depends only on time. And then I converted my ds using the formula right here, which when we plugged in our derivatives and simplified, just became root 5 dt. And so that's coming from, here was our ds formula. Here was the part where we said just replace all x, y, z with parameterization. And then our next step had been check that only t is in our integral. That's true. I got rid of my x's, my z's, and my ds. This is just an integral with respect to t. And I just need to make sure I have bounds. So I go back up here and I say I identified that t goes from 0 to pi. My integral is now with respect to t. So my bounds are just from 0 to pi. And what's a different color I could do? I'll just put a little like star here. And then we'll put a star here to show that that's where those values 0 to pi came from. And so my final form is an integral from some a to b, something that depends only on time with respect to time. And that's exactly what I'm seeing here. 0 to pi, function of time with respect to time. And from here, it's just evaluating a 1D integral like you're used to. This one's going to have like a u sub in it. I'll say u equals cosine t, so du cancels out the sine t. But you watching me do that, I think, is not really a good use of your time. So I'll just go ahead and tell you that the answer, if you want to, flex your Calc 2 skills, should be 2 root 5 over 3. But I'm going to leave this here, and we will move on to another Calc 3 type example.